about scale up, which is literally just changing those SKUs, from standard to premium to isolated. But within each of those SKUs, there are 3 levels, and roughly each level doubles the previous level in terms of the amount of CPU and RAM that is available. For reference, a P1 V2 costs about $140 US a month for one instance. A P2, double it. A P3, double it again per instance. For me, this actually goes back to one of the key things I like to do is use the smallest possible SKU and size of machine to achieve your base scale before adding more instances, which is called scaling out. The reason why I like to do this is it helps us control cost. If we're talking about scaling out and adding additional instances, and we're running say an S1 instance, which is $70 a month versus that P1 V2 instance, which is $140 a month. If we scale out and we go to 2 instances, between the 2 SKUs, that's a huge difference. You're talking $140 versus $280 a month, just by that one scale step. And then each increment beyond that, it gets higher and higher. Within Azure, we can scale out by we add additional instances. We can do it automatically based on load through auto scale options, or we can specify explicitly how many instances we want to have at any given time through manual scale options. These instances are automatically load balanced via the Azure service. It just takes care of that stuff for us, which is really, really nice. So autoscale is a great tool. So we've got a little graphic here. Imagine our website walking along. I'm going to represent the number of instances we've got, and the purple line is going to represent the load, how much traffic is coming to these websites. Okay, so we're getting up to the capacity of what we can achieve with our one instance, but autoscale can kick in and provision another instance. And as our demand for our website increases, we can provision more instances, and then we can start to, as the demand tails off, we can provision back down to our baseline. And this can be configured and set up automatically. Pretty handy tool. I'm going to show you that. So, all right. So my demo tenant. Let's just use this one. Get that out of the road. Why can't I collapse that? Okay. Anyway, so I've got some app services that we've provisioned. I've got some in West Europe. I've got some in West US. I'll just grab this first one. This is the basic view of our app service. In the left-hand pane here, we have a bunch of different options. You'll notice those words scale up and scale out. Sven, I am sharing my screen. I think I might be spotlighted, Demir. Could you kill that spotlight?
Yes.
Thank you. All right, so I'm going to choose scale up. This allows us to select new sizes and additional instances. I'm running an S1. It's nice and cheap for a production workload. Until yesterday, I was running this on a much, much cheaper SKU so that I didn't run up a whole bunch of compute costs on my demo tenant. As you can see, we can just click a button here, press apply, and we'll change the amount of compute that's available for that website per instance. I'm not going to do that right now because S1s are fine for the demo purposes. For scale out, we can configure our scale rules here. So by default, this is set up as a manual scale, and it has a fixed number of instances. I can come in here and I can say, actually, I'd like 5 instances, please. If I hit save, it will go off and provision additional instances, deploy the code that we've got deployed into our site onto it, join them into the load balancer, and then start serving requests with them. So a couple of things to think about with this. What's the startup time for your app as you add those new instances? Because most of us, I will assume that a lot of us here are running apps that are using .NET Core or .NET Framework. Those have a JIT step, just-in-time compilation step, which adds to that startup time. Maybe you have to go off and fetch data during startup. So those are things that can, as you add new instances, they're going to help, but there is that startup lag where you're going to have some high compute costs for that first little burst. What's interesting here is we can actually hit custom auto scale. And this allows us to configure rule-based changes to our scale. So by default, we don't have any rules set up. So we're going to add some rules. And it's going to look at what the underlying instant plan that's running all this is. Criteria, we have some choices of how we're aggregating, whether we're using sums, minimums, maximums, averages. Depending on which metric you're using, you want to choose the appropriate thing. For example, CPU, an average of CPU is a really good choice. If you're looking at perhaps HTTP queue length, maybe you want to look at the maximum. We actually do look at configure a rule for some of our stuff where if our HTTP queue length is over a certain maximum threshold for a period of time, we will scale. But anyway, we'll use the CPU percentage. It tells us what the current percentage of use of our CPU is, so that's really useful to just be aware of as we go in. So we're going to scale if our CPU usage is greater than the default they suggest is 70%. Often I'll kick that down a touch because I scale conservatively. How long is it going to look at the data of that metric? So it's going to look at back 10 minutes and take 1 minute chunks and average the time across those. Now, what we're saying in here is that if our CPU average over those 10 minutes is over 65%, we're going to add 1 new instance. We could change this to be 2 or 5 or any number, and we're going to wait 5 minutes before we add new instances again. So that cooldown, that's to allow us to ensure that we don't get into a case where we're scaling on CPU, but that startup cost of the app has a massive CPU spike, and we can get into a sort of a storm of scaling. So we're adding new instances, and because they have a spike in CPU at the start of them, and as they start to serve new requests for the first time, we're going, oh, it's causing us to scale again. I've seen that happen. This cooldown value of 5 minutes is actually really useful. In fact, I think that, no, it's the duration that they warn you. Yeah, so the duration, they warn you if you try and set it to anything less than 5, because that's just looking at too short a period of time to get a good picture of what's happening. So I'm just going to click add, and it's going to create a rule. If you're creating scale up rules, it's a good idea to create scale down rules as well. so that you don't scale up, and then come back and go, "Oh, that cost a lot yesterday." Cool. So if I hit save, now my system's sweet. It's going to scale up to the maximum that this SKU will allow, right? Not quite. There's one little trap in the instance limits here. By default, it says minimum 1, maximum 1, default of 1. If I leave this as it is, that scale rule is going to do absolutely nothing. So you need to make sure that you set your maximum to a maximum value that makes sense for you, that isn't 1. Little trick, S1 SKUs have a maximum count of 10. You can't put a maximum over there. So Azure's pretty good about telling you when you're trying to configure things that are not within the bounds of what you can do, or where there are challenges with what you're trying to do. So that's a quick overview of how you can set up these custom auto scale rules. I'm not going to save any of those changes. I just wanted to demonstrate how we do that. I'm going to jump back to the presentation. Now we're going to talk about how this can be problematic. So auto scale can actually be a case of auto fail. Consider the case where your demand for your website grows and the rate of growth outpaces by a significant amount your auto scale rules. Everywhere you can see in this chart where the purple line is above the number of servers stacked there, you're going to have users who are having a bad time. They're going to have slow responses, failed responses, those kind of things. So autoscale is a useful tool to use, but it's not going to save you in all instances. So it's a tool, use it with care. Take a look at what's happening with your system. If you have known swings, you can actually even set up scheduled scale events at certain SKU levels. Understanding what those spikes and curves of demand look like under normal circumstances for your system is really useful. And that's where these kind of auto scale rules absolutely shine. But they are not a magical cure-all that will solve all your scale problems. Anyone that tells you different is selling you snake oil and is not to be trusted, or they just don't know what they're talking about. So another thing to consider with location, with scale, is where are your servers in the world? So imagine we have a deployment in the East US. And we have Eric, who's sitting in Texas, and he's nice and close. He gets really good response times from this server. Then Tracy comes along. Tracy's over in South Africa, and unfortunately, the ping time to the East US from South Africa, it's pretty poor. And it's going to take longer for those web responses to get to Tracy. It's going to take longer for her requests to get to the server. So you might have a website that's performing really well and delivering those bytes off its box really quickly, but because of the latency, it's going to appear slow to a user. Great thing with Azure, there are data centers all over the world, so we can actually address a lot of this. So we could go and deploy an instance into South Africa North, for example. Configure up a tool and ensure that Tracy's requests get routed to the South Africa North instance while Eric stays on the East US. One thing I'm going to cover off with this. Azure has this notion of what's called regional pairs. So if you're doing a multi-region deployment, you should go and look at the business continuity documentation on the Azure Docs that cover off regional pairs. What a regional pair is, Azure guarantee that they will only update and perform maintenance on one of those two data centers for a given service at once, and they won't deploy to the second or perform the maintenance until they're happy with the results of it in the first. So this is really good to ensure high availability and that your users don't have a bad time because Azure's shipping updates to the place that you've got your servers hosted in. If you choose to deploy, say, to other regions outside of that pair, so you pick two regions that aren't paired, it can happen that the updates are deployed to both of those regions at once. So your business continuity can be impacted if that happens. So just a little tangent, but really worth considering when you're starting to look at high availability scenarios. So when it comes to spanning data centers, putting a deployment in multiple regions, Azure has two products that allow you to work with this. The first and their longest running one is a product called Traffic Manager. It's a DNS-based tool. It works with any protocol. It's just full TCP/IP. Doesn't care because it's DNS-based. It lets you do things like cross-region redirection, ensure that you've got highly available systems. Because it's DNS-based, you can actually use it to have an on-prem deployment and a cloud-based deployment and ensure that your on-premises users use the on-prem instance and the people who are out roaming the world use the cloud-based instances. With Traffic Manager, all your SSL termination is at the underlying infrastructure. So if I have multiple regions, I have to deploy my SSL certs into each of those regions. You have to supply your own certs with Traffic Manager. It doesn't provide any additional security services. It's just a DNS system. The other option, and much more recent addition to Azure's products, is a thing called Azure Front Door. Now, this is an HTTP-based system. So if you're looking to do this with webhooks, WebSockets, Front Door won't work for you. It's only HTTP. It does what we call request-based routing. So imagine that I have my website, myignite.microsoft.com, WAC, Europe. And I've got this page hosted at area of the site under a path WAC Europe. I can choose to configure a rule within Front Door that says, I see this path for Europe. That means all of that traffic is going to be routed to this set of servers over here, while the rest of the traffic is going to be set to these. So this allows us to do really cool things, path-based segments to different infrastructure. So you can have multiple function apps, for example, providing functionality under different paths of your API. Front Door provides SSL offloading. So the SSL termination can happen at Azure Front Door, and within the Azure data centers, all of the traffic is purely HTTP based. For some people, this will introduce security concerns, but it comes with a large benefit to performance and management, because SSL Front Door can provide that SSL cert if you want to, and you only have to manage the SSL cert in a single location. Front Door provides a web application firewall by default with a whole bunch of really useful rules, and it also provides static caching, or content caching of static content, and that's configured by default. Now, I'm going to show you a little bit of this. So, back to our demo. All right. Okay, open this back up again. I'm just going to bump up the zoom a little here and collapse that. All right, so what I've got in my resource group here, I have a traffic manager and an Azure front door instance. They're right underneath each other. I'll start with the traffic manager because it's possibly the simplest. What we've got under our endpoints is we've got two endpoints. Just open up the West Europe one. We can see it's targeting an Azure app service with this target resource. And this traffic manager is configured in performance mode. Performance mode, that's great. That means it's going to pick the fastest server, right? No, this is DNS. What it's doing is when me as a user makes a request for the URL that this manages, the Azure front door system works out what the lowest latency from my location to any of the locations it has, and I'm provided with that DNS entry. There are a number of other configurations, things like weighted, so we can actually do, split 60% of the traffic to this region and 40% to this region. So you could use this to do things like A/B testing of your systems. You can use priority. So you can set up a primary failover system. Geographic routing lets you ring fence certain geographies on the planet and route traffic there. So you can have a traffic manager sitting at the top of your configuration that says, we'll take all the US traffic and direct it to this traffic manager, which will then use performance routing within the US to select which region. And then we'll use Europe and it'll send all our traffic over here, but it's actually going to be that traffic manager for Europe will be set up in weighted systems. So you can nest traffic manager configurations. It's kind of neat. One of the interesting things here is they're doing continuous probes of the underlying services to ensure that they're healthy. So this configuration checks those endpoints every 10 seconds. It'll allow 3 failures. And by default, I've configured this to fail really quickly. So it times out after 5 seconds. So if it goes, hey, are you there? Are you healthy endpoint? After 5 seconds, if it hasn't got a response, it fails it. I think the default's 30 seconds. By default, I believe the DNS TTL is actually, I suspect it's 120. I can't remember because I've gone and changed all these settings for demo purposes. Now, front door allows us to do a lot of similar things. It just does it differently. We say, hey, these are my front ends. These are the domains that we're working with. We have a pool of backends, i.e. what are the servers that we're connecting in. We can configure, how are we checking for the health of these backends? Are we using HTTP or HTTPS? We can use a head or a get. I chose head. By default, I believe it's a get. Head's just a cheaper request. Configure how the load balancing is set up to define what's healthy and what's unhealthy. Same things that we saw over in Traffic Manager, just a slightly different way of approaching these. Now, default forwarding rule. In here, by default, caching will be enabled. I've turned it off for the purposes of a demo. You probably don't want to do that unless you have some really good reason. You can also see here, we can set up path-based routing that I was mentioning earlier. So these are really cool systems that allow us to have hosts in multiple data centers and ensure that people are sent to an appropriate data center. Now, they both provide some degree of high availability. So what I want to show now, so I have some very simple scripts here to simulate some load against my sites. On the left, we've got a script that's going to hit my front door URL. On the right, it's going to hit the traffic manager URL. They have kick those off. So you can see here, control one. Interesting. I got some West Europe requests there. I was not expecting that. Yeah. Wow, that is unexpected from Traffic Manager, but we'll run with it. What I'm going to do is actually go back to Azure, and I'm going to simulate a failure. Before I do that, I'm going to open up both these websites in a brand new session. And for some reason, Traffic Manager, or Front Door, sorry, is giving me the West Europe one, while Traffic Manager is giving me the West US. But that's okay. What I'm going to do is stop the West US web app to simulate a failure. And we can see my Traffic Manager requests that are going to the West Coast are failing now. So any users who are actively using that, and we can see my my front door requests are also failing there. What we'll see is they'll both stabilize and start routing traffic to the West US. With Traffic Manager, we saw that switch over and it just switched over because it's a DNS change. So the script on the left, on the right, has just picked up that. With Front Door, it's going to keep trying those West US endpoints for a little while before it determines that, yeah, actually, we're going to completely fail over now. So we've failed over. I'm just going to stop these. So this is great, right? Both of these systems provide us with nice, clean failover. There is a small problem. Traffic Manager, because it's DNS-based, has a bunch of the problems that come with DNS. This browser has picked up and cached the DNS response it got when I first opened the browser and said, go to tm.gavinb.net. If I open a new browser, it'll work fine. But this is one of the weaknesses with Traffic Manager. Users who are already on the site might take quite some time before their browser decides, oh, actually, you can have the new DNS entry now, even if the underlying computer that's using this has picked it up. It's a little bit of a vagary that's annoying, shall we say. Cool. So we've looked at Traffic Manager and Front Door. I will say this before we move on. If I was building a new system from scratch and I had the choice, I would be looking at Front Door first. It would always be my first choice unless there was a key reason why Traffic Manager was necessary. with the solutions that we're using for all of the Microsoft event websites, we're using Traffic Manager because we built those systems and set them up way before Front Door was available. And if it works, it works. And we haven't had a compelling business reason to make the change. Monitoring. How do you know that your websites are doing what you want them to do? First thing is start capturing telemetry, use application insights. It's usually configured. So if you're configuring an app service via the portal, it's just part of the default configuration. You'll need to go and add that app insights telemetry and instrumentation to your code, particularly if you want to capture information from the browser. There's a JavaScript snippet you need to drop into your HTML, and you should definitely log that information, because the health of your system for a website isn't just what's happening on the server. It's what's happening on the browser as well. All of your API responses can be fine in 200 and nice and fast, but if what's happening in the browser is not good for the user and there's crashes, you need to know about that as well. Take care with this. We separate all of our telemetry by deployment environment. So we have a UAT environment, a pre-production environment, a test environment. Every one of those environments has its own application insights instance and only logs into that, because you don't want to muddy the waters of your production telemetry with data from your test environment. Relatively simple to set up. You just need to make your application insights instrumentation key part of the configuration that you deploy. Watch out for what you're putting in your logs as well. If you're logging errors or exceptions or error messages, make sure that you're not putting any personally identifiable information into those logs. That's a bad call. Depending on what your retention policies are for that logging information, you could find yourself in a GDPR pickle because someone says, oh, I want to be forgotten, but you've logged their email address into application insights, and that's a bad idea. Now, I love application insights, but some of the decisions that they've made present challenges. Let's put it that way. The default configuration for application insights is geared towards being, let's say, budget friendly. It's aimed with the idea of ensuring lower cost. How it does that is by reducing the amount of telemetry that it captures. It does this thing. I've used the word throttling on the slide here. The correct term is sampling. It samples down the amount of information that it sends via the SDK to the actual service to reduce data costs and network traffic costs. That can create some real headaches. So this is a chart from some load testing we did. Wow, each one of those dots is a minute. Apparently we managed to get to 4.5 million requests in a minute during some load testing. It is complete and total and utter lies. We got nowhere near that on this load test. I think we got into maybe a few 100,000 requests in a minute at that point in time. The other thing to call out is that the shape of this graph, where it's spike, 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 that should actually be a nice steady increase and then a flat curve across the top. We see this strange shape because what's kicked in is this sampling effect and it skews the numbers. The default configuration for App Insights is to only log five data points per server instance per second. So you can see, so what's happening is if I've got 100 requests or 100 different telemetry data points that could be logged in that second, 95 of them are discarded. And each of the ones that are retained have an item count attached to them that represents how many items did we discard to keep this one. So you should be able to use those to create this approximation to the real world. Unfortunately, in the real world, that approximation just doesn't work because the sampling is incredibly painful. Good news, we can change this. This is a .NET Core sample. In .NET Framework, you can do this through what they call a configuration file, applicationinsights.config. It is the strangest way of setting this up that I find it bizarre, but what we do is we say adaptive sampling, false, turn it off. And then actually, we'd like to turn on, we're going to say AI config builder.use adaptive sampling. And we're going to say, we're going to take 100 requests, 100 items per second. You can change that to any number you want. And we're going to exclude requests from sampling. So turn off adaptive sampling and then turn it back on with your new configuration is the flow to how this needs to be set up. The excluded types, you can exclude any of the types that Application Insights logs. So you could choose to completely turn off adaptive sampling, or you can just turn it off for specific types, requests, events, dependencies, exceptions, etc. We just turn off requests because we need to have an accurate count of what's going on in that space. I will say, changing the adaptive sampling rules comes at a cost of both your Application Insights service and CPU and memory usage on the machines that are generating telemetry. So watch out for that. As you change your configuration, you need to validate that you're not creating yourself problems. When we first discovered this, we just disabled sampling completely, and we completely cooked the machine. It was impressive, actually. The RAM and CPU usage for the same workload from adaptive sampling using the default configuration to completely off doubled under the same load. So those are things to watch out for. Performance monitoring. Watch what your system does under load. Look at what happens under normal operations. Do you see that at 9 a.m. in the morning, you have a spike in usage that tails off over a half hour because everybody's coming into the office and starting up their systems or walking down the hall to their office at home? Do you see any areas where you, just looking at your data, you see problems? If you're reviewing your telemetry data regularly, you'll find some things. Just build it into the habits of your teams, right? Make telemetry review, daily, weekly at a minimum. Build some dashboards so you can see key metrics at a glance. And honestly, I'm not talking about metrics dashboards that just look at CPU usage, RAM usage. Look at actual end user facing metrics. How many requests are going to the login endpoint? How many of the requests are loading this page within your website? Because if you're just looking at CPU or RAM, you're looking at side effects. You're not looking at what happens for users, because ultimately, when we build a website, it's for people to do something. If they can't do that thing fast, they're going to get frustrated and walk away or go somewhere else. Azure has great systems for alerting. Build alerts for failures, and don't alert on every failure. Work out how you alert in a smart way. And those alerts can be things like email messages to teams. We have certain levels of issues that will just generate an email into one of my team's channels, and my team will pick it up. We have certain levels of alerts where my phone will ring. Choose the appropriate alerting metrics and mechanisms for your team. As a result of this, you're going to be able to improve performance. Some of this you probably want to look at using some load tests and looking at live site metrics during your normal operations. If you're load testing, look at different load patterns. You can do a ramp up, so you slowly increase and increase and increase and increase. And you can look at just applying a constant load. What happens if we ramp up to this point and just apply that constant load for an hour? There are things called soak tests where you apply load and you just keep it applied for 8 to 12 hours. Spike tests, what happens if we have 2,000 users jump on in this 1 minute period? Like, boom. Look at what happens under all of those different situations to understand what happens within your system and how you can improve it. Looking at your live telemetry, you can see areas where there are lots of usage that have high response times. So, for example, if your login time is slow, everybody has to log in. Well, everybody, assuming everybody needs to log in, that's a really good thing to try and drive down. There's profiler information available in Application Insights to show you, what's the hot path, where are your code issues, and if you're doing anything in terms of load testing, make one change, record the change and repeat the test. Don't make 3 or 4 changes and do another test, because when you make 3 or 4 changes and do another test, you don't know which of those changes caused the change that you see in the outcomes. So one change, one test for any form of load testing. Azure has some load testing tools now. They announced them the night before I gave this session at the European Cloud Summit. I'm going to jump over and show them to you very quickly. We have a resource group called Load Test, and we have a thing called our ECS Load Test. First of all, I want to show you what this is. It is just the to-do app. It's backed by Cosmos database. I'm hopeful that it's actually up and running because I forgot to refresh this morning. That's not useful. In the load test system, so cool. That's now up and running. It's gone through its startup. Within the load test system, we can just create a new test run. This uses a tool, an underlying testing framework called JMeter. You just upload your JMeter script. Grab this one, click upload. You can add additional configuration files. This is a really simple JMeter test. All it does is go in, load this screen, and then randomly select one of the detail pages to open for a given test iteration. You can add additional environment variables to your tests. So if you've got to pass secrets or things like that into your test runs, that's all available here. We can say how much load we're going to apply. So how many engine instances. It's kind of cool. They actually say, hey, look, when you're building your tests, set the maximum number of threads in your test to 250. That way you can understand how much load each of those tests will apply as you add what they call engine instances. So basically load test agents that are generating load. I'm not going to use 45 instances, so that would take quite a while to provision. We'll just use one. Hey, what does success look like? Unfortunately for these, the aggregates here, average response time, I'd much prefer to see a percentile here. It's an alpha pre-release product. So let's say 600 milliseconds. If we exceed that, that's a fail. And our error rate as a percentage, if it exceeds 0.05%. We can choose what resources we're going to monitor during this. I'm actually just going to scope that down so that I only choose the resources in that resource group. So these are the things it's going to monitor. And we're going to click create. It'll go off, set up some infrastructure in the back end and run that test for me. While that happens, we're going to go to the application insights instance that we've been talking about. Over here, there's this kind of cool thing called live metrics that lets us look at the data as it's being created effectively. Gives us some live dashboards to see, what's our request rates, how many dependency calls are we making, what's the overall health of this system. We can see what servers we've got online, how much memory, how much CPU. So we can see here the load test systems applying some load into our website. So that test run it's a 90-second test run, so it runs pretty quickly. This is a really neat tool to just see what's going on. I use it all the time during the execution of these shows that we do so that I can see what's happening at a glance. Hey, we had some actual dependency failures. That's great. My bet is we didn't see any request failures because they were requests to document data, Cosmos DB, and the Cosmos DB SDK will retry a certain number of times before it actually fails the request. So we can see if we jump back to our test run here, it's actually gone and done its run. It's run for across there. It's actually, they've improved this to actually update live. I like this. Good to see that they've been revising this since I first started using it a month or two ago. So we've completed our run. It's crunching that data way faster than it used to, which is awesome. Our response time was green. Our error was green. Our average response, 90th percentile response time was 310 milliseconds, so it's nice and fast. We can see these graphs that give us, requests, users, response time, but we can also go and look at, requests to document DB, what that looks like in terms of throughput and consumption, CPU usage, memory usage on the actual app services. So these are pretty good. And one of the nice things about this tool is there are tools, we can integrate it into our Azure DevOps pipelines. So you can have an automated test as part of your just standard quality assurance mechanisms that are run on every build if you want to. That's the load test system. When it comes to architecting for scale, I'm going to use a scenario that we dealt with. First of all, I want to give you a quick overview of what our architecture looked like for the digital venues for these Microsoft sites. In the middle, the digital venue, that's the part that my team is responsible for. We're dependent on a registration system where people sign up and say, yes, I'm coming. And we're dependent on a system that provides all of the sessions that are available, the speakers that are available, that kind of stuff allows us to say, yes, I'm going to attend that session. We have a simple website, relatively speaking, powered by a C# based REST API, which depends on Azure Search and Cosmos database. Our Azure Search is populated through some web jobs, which we call indexes, which query the other systems and put data in there. Relatively straightforward. So we've got two app services, nice and fine. The first thing we did to improve our performance was add a CDN. We had all of these static JavaScript files, CSS files, and the like that we were serving just off our web server. Adding a CDN was a great change for us. It was nice and easy, and it ensured that we had a globally replicated set of static files, so they're being served nice and close to our end users. As a result, that reduced the amount of pressure on the underlying website, because instead of requesting the image on the home screen from the website every time someone loaded the website, it went to the CDN, and the CDN would infrequently reach back to the website and grab that. That was a nice, easy one. We had to do some work to rewrite some URLs, but simple. Our sign-in process. This thing has been a little bit of a challenge. I'm going to just walk through this and I'll jump back to cover it off. The process for us to sign in a user, they go to Azure B2C, they authenticate there. They come back with, this is who I am. We now need to prove that they're registered and create a token for them to use our website. To do that, we make a call. Let's see if I can do this. This call here is, oh, no, that's not the right one. So we call the registration system to say, hey, do you know about this user? Can you tell us, are they registered? Who are they? Once we've done that, we call off to the session manager system so that we know who they are, and we can add sessions to, or allow that user to add sessions to their schedule. Once that's done, we do a put back to the registration system to record, hey, this user signed in at this time. Not too bad, relatively straightforward. We can see that the call to find by third-party ID is kind of long there, but it's not too bad. Now, March 2020, we start applying load that 15, 20 minutes before Satya's keynote. What you will have hopefully noticed is that those requests to find the data and update the data in the registration system, they just got proportionally quite a bit longer. What we were seeing is that that load was elevated. And what we found was that those increased times to load profiles, that would happen for about 90 seconds, and then they'd be good for about another 3.5 minutes. And then we'd have 90 seconds of slowness as we tried to sign people in. Okay, let's go back a little bit here. So we've got this indexer. This indexer runs every 5 minutes, and it gets information about users to update the search profile. What was happening was the pressure that query to update our data in the background, combined with all of the users signing in, was creating periodic spikes in our duration to sign in. So we changed the system. Instead of using a web job that polled every 5 minutes, we created this thing called an attendee indexer, driven off webhooks. So the registration system would send us a notification that, yes, this user has changed their profile. You need to update their record in the system now. We found that was a huge shift. By moving from polling to a messaging-based system, we got some massive gains. So this was cool. What we saw after we implemented that get was nice and fast, but that put at the end was still problematic and slow. So we made some more changes. As we stand now, we're using Redis cache to do a whole bunch of caching on our backend. We've moved all of our indexing process to Azure Functions. But during that sign-in process, instead of interactively going back to the user profile system, we actually changed it to a queue-based system. So we would drop a message onto a queue and have an Azure function update the user profile system asynchronously. So it wasn't part of the critical path to signing people in. What we found, though, was that every time someone signed in, we would see this create if not exists send message. What's going on there? That seems like a lot. The developer in question had made a mistake where every time the request to put a message onto the queue came in, they would validate that the queue was there. They wanted to make sure it was really there. So, by looking at your telemetry, you can spot things like this. If we hadn't gotten into the practice of looking at our telemetry, we probably wouldn't have picked up this bug. That was a few hundred milliseconds. By just changing some of our dependency injection pieces, we were able to get rid of some calls that were slowing down login. So reviewing your data about what's going on in your system and taking action to change the architecture of your system are really good practices as you start to scale. We've got a little bit more time, so I want to actually jump back over to the Azure portal and show you a couple of things that are what I would call hidden gems of Azure App Services. So I'm going to go into this app service. So I call it a hidden gem. It's not that hidden. So this tile here, diagnose and solve problems, or this entry in the side. Gotta love live demos when you're just doing it off the cuff and it decides we're going to get it. Hey, here we go. So this is the App Service Diagnostics Toolkit. You can look at this to actually assess problems that might exist within your system. There are some diagnostic tools in here which are fantastic. Let me go into hopefully this one. Yes. So if you find that your CPU is spiking and staying high and not coming back down, you've probably got a deadlock in your system somewhere. What you might want to look at using is this thing called proactive CPU monitoring. And I haven't got always on turned on for this. So let's jump back and do that real quick. Another little site. We're taking tangents here. Hopefully you're finding this useful. So under general settings, we can turn on always on. Great. This means that your app doesn't shut down when it's been inactive for a while. You can use this to reduce or mitigate the impact of startup time. Useful. However, there are a couple of settings within the default configuration for an app service that I would deem to be suboptimal. First of all, FTP, it's all on. It's on by default. Like nobody uses FTP anymore. Disable it. It's a security hole. At the very, very least, set it to FTPS only. Yeah. HTTP version. All the modern browsers support HTTP 2.0. Turn it on. You get small incremental benefits out of this over HTTP 1.1. This thing called Arr Affinity. And when we talked about scaling out and adding additional instances, what this does is set a cookie on the client so that their requests will go back to the same instance if it's available as when they first started interacting with the system. In general, you should be designing your web services and web servers so that they are stateless, so that the consumer doesn't care which instance out of 15 they interact with. Turn that off, particularly as you're scaling out and adding more instances. If you've got this Arr Affinity on, okay, so we've got a lot of load on this server and we add a new one, but all the users are still hitting this one server. It mitigates the benefit of scaling out sometimes. So just watch out for these kind of defaults. All right, so wait for this to update. Go back to our Diagnose and Solve Problems tab. Diagnostics tools. Proactive CPU monitoring. So what we can do with this is actually set up to grab stacked memory dumps when the CPU gets too high. We can also set it up to kill the web server instance and restart it when the CPU usage gets too high. This can be great if you've got a deadlock in your system. I'll just use an existing one. Or no, I won't. It needs a storage account to write the diagnostic information into. So we need to create one. There are so many useful tools in here. Grabbing memory dumps, .NET profiler traces, network traces. One trap to look out for. This is super deep ASP.NET stuff. if you are creating HTTP clients, they should be singletons and be reused across all of your system. Otherwise, you can run into this thing called SNAT exhaustion, where you actually exhaust all of the NAT ports on the site under load. It's kind of gross. Anyway, with CPU monitoring turned on, I'm just going to zoom this back out a little bit. Hopefully that, here we go. So what CPU threshold are we going to kill our machine at? How long has it been up there for? How frequently is this rule going to be monitored, evaluated? We've got three options, or four, sorry. Kill, collect, and analyze. If you want to get memory dumps that you can use and understand how and thread dumps and to diagnose the actual problem, kill, collect, and analyze is probably where you want to be at. So these rules will only run for up to a maximum of 5 times. And how long is this going to run for before it shuts itself off? So these things come with a cost. That's nice and easy. What'll happen is if that for some reason that instance gets above 75%, it'll kill the instance and restart it, grab the data and let you dive into that later. These tools are incredibly useful, and I feel like people don't know that they're there. So hopefully you find this useful to support your debugging and diagnosing and solving of tricky problems. Okay. All right. So over the last few years, I've learned a lot about this stuff by executing at scale. You learn by doing things at scale, and you'll find things that don't work, that worked just fine. That login issue, we didn't see that when we had 30 and 40,000 registered attendees. It took us getting over 200,000 registered attendees for that issue to come up. Because those things occur as you grow in scale, you need to evolve your system to meet those new challenges. Small incremental improvements add up. Honestly, this is a game of progress, not perfection. You want to make things better a little bit at a time. Don't try and aim for perfect because you'll never get there. Look at things that really help your users. Login is a great example because it's everybody logs in. That was a super hot spot. It was a source of friction and pain for our team. By focusing on that and improving that area, we made everybody's lives better. Your monitoring dashboards must have real user measures. You know, having CPU RAM, that's great. But if you don't know how your users are experiencing your website, you're doing it wrong. Have a brownout plan. So understand what your system does as you apply load and have a plan for how you respond as things start to degrade in performance. And that can be just as simple as we will add more instances. That is at that is the most simple brownout plan in the world, but it's valid. Richer systems might actually take the step of disabling some features within the system to reduce the compute load and ensure that the most needed features are available to everyone. One of the things that is key is working with all the stakeholders across your system. Nobody builds a system in isolation these days. There are stakeholders everywhere. So you've got to have an open line of communication with them and be able to explain why you believe changes are necessary, what those changes will cost, and how they will benefit your users. There are a bunch of tools out there from Microsoft and others. I would encourage you to look at the cloud design patterns, the well-architected framework as two great starting points for building cloud-enabled systems. So thank you all. Hopefully you found this useful. If you have any questions, please just come off mute.
Thank you so much, Gavin. It was a great. I'm very happy that you found the time. Happy to having you here because you're the guy who really deployed it in a high scale, all of that in the app service. And I hope some folks here in the call had opportunity now to see and understand how all these Microsoft huge sites like Ignite, Build, and so on, what you are everything doing, how they really work. And I see it needs 1.5 hours. Definitely, there is not enough time to dig into details and so on. And that's sorry about that for everybody. But if there is more interest, we can maybe follow up and to pick something because you showed really a lot of just a traffic manager and Azure front door. This is totally, completely story for itself. Yeah.
Mm-hmm.
And I don't know if anybody in the call has some questions. I have a bunch of them. If nobody raises a hand and asks something, I can start with my. Anybody, anything? So first of all, I would just like to recap something, all your story here and what you're showing up. And the first was the problem. You started with a simple size and you show us how to deploy something in a single region, which works. And then this is getting slow over time. And then you have shown us how to scale up and scale horizontally. And then this is all. Could you please maybe provide a little bit more information? How did you do, what is the best practices to deploy a same site or say web app, let's say this way, or your API app or whatever it's of that inside of the app service to the multiple regions?
That's a great question. We actually use Azure DevOps as our mechanism. We use deployment pipelines, and we actually do use a tactical matrix deployment, which allows us to fan out and deploy into multiple regions in parallel. So we'll deploy into the staging slots of all our websites. Mm-hmm. We'll have some quality checks and safety checks and pause until all of those staging slots are deployed, validated as healthy. And then we will go and swap all of those staging slots into the production slot. So that's actually kind of our tactic.
Okay. So actually you use DevOps pipeline, just standard as most of folks here probably in call use. And so you have a pipeline which deploy in a single site, and what you do then with to multiply in a multiple locations. How many locations did you have, for example, to Ignite on this?
So by default, we do 2 locations, East and West US. That's our standard configuration for HA. During the events, we scale out to additional regions around the globe.
And this is doing additional pipeline or the same one? How do you do that?
Same pipeline, just additional steps in the matrix deployment. So we have a template deployment that we use in a matrix step.
And you just change probably the region in the template.
Yep, we change the region and some other inputs into that pipeline, into that template.
Okay, this is a cool.
It's fully parameterized. Yeah.
And in how many regions you host such event?
Usually we go to 6.
6. Okay, yep. That's interesting. Which 6? 2 in US, I guess, or maybe 4.
Usually with 3 in the US, 1 in Europe, 2 in Asia.
1 in Europe. That's okay.
Yeah.
Just 1. Okay.
Yeah, honestly, it's down to numbers. We looked at where our traffic was coming from, and the split was 60% the Americas, about 20% Europe, and then about 40% Asia, APAC, EMEA.
Interesting. I didn't. I expected a little bit more in Europe, but okay.
Yeah, I was really surprised by it too. But yeah, it was a data-driven decision.
Or maybe we'll change it over years.
Yeah, I hope so.
Yeah. Okay, we will see.
To be fair, we have had in some shows, I think Build, we had 3 deployments in Europe for, because the first Build, because we don't know how this is going to go. We're going to deploy everywhere. That's one of the beauties of Azure, right? Like, you can always throw more compute at a problem, but you want to try and be refined about it and do it in a way that's cost conscious and appropriate.
Yes, of course. Another question, this application, registration application around event, is that application you have developed or somebody else?
No, it's a partner organization who also has developed that and maintain and run it. They're also deployed in multiple geographies and are highly available as well.
This is great. We love in the community to see how Microsoft uses its own technologies to do big things. And that's really great story. Thank you very much for that, for sharing this information. And I have any question in the meantime? If just interrupt me and raise the hand. What do you think? Why didn't you do that on Kubernetes?
Honestly, because when we first started building this in 2015, Kubernetes really wasn't a thing. Like, we built this originally, we built this for the first Ignite in Chicago, and we've just evolved the system ever since. I've considered Kubernetes a couple of times. Honestly, because of the skill set of my team, PaaS systems work better. Kubernetes requires a lot of feeding, watering specialist skill sets. I don't have those folks.
If you would start now from the beginning, would you do that?
I would be definitely considering a Kubernetes-based system now.
Okay, you would be considering that. That's okay.
Yeah, fine. Absolutely. But that said, right, you've got to match it to the expertise of the people who are building and deploying and running these systems. So there's a trade-off.
Yeah, that's definitely. I'm asking this question because many reasons. We have attraction in the community, like 1 or 2 years, especially in the last year, where the people are jumping on Kubernetes, which is a great technology, no question. And I also know people who use all the time app services, only app services, mostly app services. But I also know the people who say, I would never use app service for a really professional project. So, which is really interesting. You are using it for extremely professional thing. And it works. So that means we have many options there, which are also simple. And that was the reason why I'm asking that. So there is a consideration to use both of them. And you answer already the question because of skill set. And it is probably mostly a driving factor. Any question? Okay, it was just some thank you. So could you please maybe provide a little bit more information about adaptive sampling? I find that personally very interesting, where you switch on tune a little bit adaptive sampling and you slow the performance of the whole solution, which is
so what we found was when we disabled adaptive sampling, and so we were processing every single telemetry item, it created a massive increase in the level of RAM usage and CPU usage, because it had to process every item as opposed to discarding them and not worrying about them anymore. It was interesting, and one of those things where you definitely want to test this out and see what the impact of all of those changes are in a test environment before pushing it out into production. Really glad that we, were able to pick that up during testing and find out what was going on.
But this is really interesting observation because actually you show up some 4.6 billions, if I remember, a request which was not true. Yeah.
Nope, not the truth at all.
Can you maybe explain that a little bit more?
Yeah. So just give me a sec and let me jump back to that slide. Where is it? Here it is. Just going to restart this and one sec.
Yeah, that's one.
That's the one. So where this comes in is, so this is done by creating a sum of the item counts in every minute. Now, remember, we're discarding all but 5 telemetry items, and it doesn't actually, excuse me, it may have discarded, say, let's say 100 dependency items and recorded them in the item count of the request. So it's across all types that the sampling's happening. So what happens is the item count for that's recorded is massively elevated because of all the other discarded types, the events, the traces,
Was that the
non-request types.
Was that the reason why you show up the code snippet and configuration in .NET, which switch off that and then remove request items, something like that?
Yeah, so in this sample here, the excluded types means don't use adaptive sampling on these types. So there, every request gets recorded, and out of the rest, we'll record 100 telemetry items.
Okay.
Yeah. So it's a little counterintuitive as you read it for the first time, but once you grok the underlying mechanism, it makes sense.
Yeah, interesting. That's a really great story. And last, but not least thing, least but not is App Service Diagnostic stuff. Okay, so this is really a great story because many people actually never use it, and many people don't know that they are there. And maybe you can, if you can share a few more information about it, because not only it depends on how you deploy your service on Windows, on Linux, and Docker container. It depends what happened, really.
Yeah. So, like, there are things like auto heal, which lets you do it. You've got auto health checks. So, like, go in here and look at this stuff. This site is just deployed, click, deploy for a demo purpose. So, I don't expect this to be perfect. The first thing it shows you is, hey, you've only got one instance here. You probably want to have 2 so that you don't get downtime when they upgrade the actual underlying infrastructure. There are all sorts of diagnostic tools. This availability and performance tool, really worth looking into, right? Why is my web app slow? Why have I got lots of CPU usage? These tools are incredibly useful, and I would urge everybody to go out and experiment with them when you're not under the pressure of things are going badly. Go and see what they're like and see what information are going to be useful for you. The web app restarted log here, we found to be useful. We had a couple of years ago, we had some instances where we actually had some restarts happening and we weren't aware of what was going on. This log helps us.
Yeah, that one is crazy one. Yeah.
So,
yes, many people don't know that app servers, depending on what is in, is around 90% of the pressure. It's just restarting the entire container where the app service application is running, independent if it's Docker container or app service one. Yeah. Well, that is a pain sometimes. Yeah. Okay, thank you.
Super fun stuff. I love to nerd out on this, so thank you for having me, and it's been great.
Oh, welcome. You are welcome. Then for everybody else in the audience, if you don't have any questions, thank you so much for attending this event. And we will have next one in a week or so. And please feel invited for that. Gavin, thank you so much. We stay in touch and hopefully see you soon, face to face.
I hope so.
Yeah.
All right.
Thank you, guys. Bye, everybody.
Thank you. Bye.